Good morning, listeners, and welcome to today's class. Today, we'll be discussing with you on the topic indices. Of course, you and I know that this concept in mathematics called indices is one that is often underrated and equally assumed by many persons to be very simple. However, there are some questions that can be called up from that area that can pose a very serious challenge if the in-depth knowledge of the laws of indices are not held at the tip of hands. So today we just have few questions which have called up to solve with you with intention of revisiting the laws of indices in totality, especially as it is applied in solving of problems. So without wasting much of your time, let us, as usual, call up these questions on the board and solve with you. At the end of which, you have a lot of dark areas on surrounding the understanding of indices completely removed. So stay tuned. Let me call the questions up there on the board. Thank you very much. The first question says, and I write, that is question number one. Question number one says, question number one. That number one says, if a raised to power a square root of a equals a square root of a all raised to power a for some non-zero, for some non-zero, for some non-zero real numbers a, then a equals what? That is the question. The question says, and I repeat, if a raised to power a square root of a equals square root of a root a raised to power a for some non-zero real numbers a, then a equals what? We are going to solve this problem with you now. And I assure you that at the end, you can solve problems like this without necessarily bothering your greater thoughts on what will I do at this stage and what will I do at the other stage. So as a way of solution, see, permit me to divide this board, or let me not divide it. So as a way of solution. The question says a raised to power a root a is given as a root what? A all raised to power what? A. I want to keep this one steady and be able now to expand this with you. Of course, you know that this A shares in this power. This root A shares in this power. So I can expand this thing this way, that I have A, which is this, raised to power A, root A is given as, I'll come here, this A here, I have A raised to power this A multiplied by, I come to this root. Root what? A all raised to power what? A. This can be written this way, of course. I still want to keep this one the way it is and equally come here to expand this all the more by removing this square root sign inside this bracket. And by doing so, what I have here becomes what? A raised to power A root what? A equals, here is what? A raised to power A multiplied by. Anytime somebody writes what? Square root of what? 2 it is the same thing as 2 raised to power 1 over what 2 in indices. Therefore, if somebody writes square root of what a, it is going to be a raised to power 1 over what 2. So I'm going to call up this law in indices and apply it here. So which means in this root a, what I have there is what a raised to power 1 over what 2, then all raised to power what a, the way it is. So this and this are apparently the same thing. Then we move further. I still want to keep this one. So I have what a raised to power a root what a is given as. Here is what a raised to power what a multiplied by. Now this power here is going to multiply this power here. Okay? So what am I going to do? Here is my 1. 1 multiplied by a is what? A. That is to say 1 over 2 times a is of course a over 2. So what I have there becomes what? A raised to power a all over 2. By saying 1 over 2 multiplied by this a. Okay? So permit me to clean up here and continue that solving there. Okay. What am I going to do at this point? We equally come for another law in indices. Here the base is what? A. Here the base is what? A. In indices, once the bases are the same, with the sign of multiplication, we take one of the bases and add up the what? The powers. So this problem becomes, what I have here still remains. My a raised to power a root of a equals. Here I will pick one of the a, which is a. What's the power here? A. So I have what? A plus. What's the power here? A over 2. I have what? A all over what? 2. Of course, when someone says what? A, and that student says A all over 1, they are the same thing. So I can quickly call up that idea here. Instead of writing ordinary A, I will have A over what? 1. So I can equally say all over 1. And if I do that, I will ask myself, what's the LCM of 1 and 2? LCM of 1 and 2, of course, is what? Is 2. So I have what? A raised to power A root what? A is given as, I have a raised to power, here is my 2. I will now see. 2 divided by 1 is what? 2. 2 times a is what? 2a. The sign here is what? Plus. 2 divided by 2 is what? 1. 1 times a is what? Is a. So what I have here becomes what? A raised to power a root what? A is given as what? A. 2a plus a is what? 3 what? A. All over what? 2. That becomes that. I now come again to another laws in indices. Whenever the bases are the same thing, they can be cancelled off and then the powers equated. That's another strong words law in what? In indices. Once the base here is the same with the base at the right hand side of the equation, the bases are cancelled off and then the powers are what? Are equated. So what do I do now? I will cancel this a and cancel this a and bring down the powers and equate them. So what I have becomes what? A root of what? A is given as what? 3 what? A all over what? 2. Okay? What do I do next? Here you can see that this my a is standing as if it were the coefficient of this what? Root a. So trying to make this root a to stand all alone, I am going to divide both sides of this equation with what? With a. So what I'm going to have here becomes what? We say all over what? A, then here becomes divided by what? By a. So that this a will cancel this a. And I'm left with what? Root of a is given as. Then here, what I have here becomes what? Here becomes what? 3 what? A all over what? 2. Do remember that any day you are changing division sign into multiplication sign, the numerator goes down to be denominator and denominator goes up to what? To be numerator. And you know that when you say divide by a, it can equally be written as divide by what? A all over 1. Because this a over 1 still remains what? A. So in that case, this my 1 goes up and my A comes down. So I will now change to multiplication. Multiply by 1 all over what? A. At this point in time, I have A here and I have A here. So what I have here becomes what? Root of A is equals 3 times 1 is what? 3 all over what? 2. However, we were not asked to find the value of root A. Instead, we were asked to find the value of what? Of A. So for me to make A to stand all alone, I am going to now square both sides of this equation in order to remove this square root sign. So what I have here now becomes all raised to power 2, all raised to power what? 2. Are we there? And then root A raised to power 2 will become what? A. This is equals 3 raised to power 2 is what? 9. And then 4 raised to power 2, 2 raised to power 2 is what? Is 4. So we now say therefore our A is given as what? 9 all over 4, which can as well be written as A is equals to what? 2 whole number 1 over 4. That is the value of what? Of A. You see the way calling up the laws of indices, different laws of indices, went a long way to assisting us now get the value of this A effortlessly. As a way of refreshing your mind once more, we were given this and we are asked to find the value of what? Of A. So what we did here was now to come here, head our left hand side almost constant, without touching it, without expanding it, till we are done expanding everything at the right hand side. What we have here is A root A raised to power A. To expand this, we bear in mind that this A shares in this power, root A shares in this power. So what I did here was now to open the bracket. Here is my A raised to power A, which is here, multiplied by. Here is my root A raised to power A, which is what I have here. Recalling that root here, whenever I have root 2, it is the same thing as 2 raised to power 1 over 2. I now said, okay, this thing becomes A raised to power A, which is what I have here, multiplied by. Trying to remove this square root here, it becomes A raised to power 1 over 2, all raised to power what? A. Using this 1 over 2 to multiply A, I have that this is A raised to power A over what? Over 2. Now, here is A and here is A. In indices, when the bases are the same with a multiplication sign in between, you take one of the bases and add up the powers. That's exactly what I did here. So it becomes A over 1, which is this A over 1, because A and A over 1 are the same thing, then plus A over 2, which is A over 2. Okay, trying to add A over 1 plus A over 2 brought us now towards 3A over what? Over 2. At this point in time, we realize equally that we have A here and we have A here. And the bases are the same. And equally in indices, once the bases are the same, we cancel off the bases at the left and the right hand side of the equation and equate the what? The powers. So I cancel this and equated this to this, which is exactly what I had here. Cancel the A and cancel A, equating what? A root A, which is what? A root A. So if I cancel this and cancel this, I will equate A root A to 3A over what? Over 2. At this point in time, we realize that I have A here, which I can easily use to divide both sides of the equation to make root A to stand on alone. That's exactly what I did and arrive here. Remembering that I was not asked to find the value of root A, but A, I took the square root of both sides. And when I did, of course, I now arrived at A is given as a 9 over 4. That is how to solve this kind of a problem. Please do remember still to subscribe to our YouTube channel. We are committed to bringing transformational change in you about the concept of mathematics and statistics. Okay? So stay tuned while we continue to make efforts to be teaching you in a very most transparent ways. Subscribe to our YouTube channel so that the moment you upload a class, you'll be able to get the class firsthand. Thank you very much and stay tuned for our next class.